Welcome everybody. This video is part 2 of 4 on performing operations on real numbers. In the previous video, we looked at how to take the absolute value of a number. So if you haven't watched that video, go check it out now. In this video, we're going to talk about how to add, subtract, multiply, and divide real numbers, as well as apply exponents to them. Let's jump in. Let's start by looking at how to add real numbers together. Typically, when I add two numbers, we can think of that as just moving to the right on a number line. But that idea can get a little bit confusing once we start throwing negative numbers into the mix. Like in part A, for example, of this one. How would I exactly move to the right negative 14 units? Well, I would move to the left because I'm moving opposite of to the right, 14 units. A good way to just kind of wrap all of this up in your head is when the numbers match signs, they go further in that direction. Right? We wouldn't hesitate thinking about how to add two positive numbers because we know the result is just going to be more positive. Similarly, we don't have to hesitate with adding these two negative numbers because the result should just be more negative. I can add them as though they were positive and get 26, and then I just have to make sure my sign matches. Negative 26. Same thing goes for part B here, except now we don't have the same sign. We are starting from negative 0.3 on a number line and moving 0.7 units to the right. This ultimately sort of works like subtraction. Notice I've got one positive number and one negative number. So what I can do is subtract them in the way that's easiest to do that, which might be minus 0.7 minus 0.3, and that would get me 0.4. Then all I have to do is make sure that the sign on my answer looks correct. And the correct sign in this case would be positive, since 0.7 was the larger number. Last but not least, let's do a quick refresher on how to add fractions, because this is one of the most common mistakes I see as a math teacher. Even as you go upward into your sophomore and junior years, I still see this mistake happening pretty often. Remember, to add fractions, we need a common denominator. You may have been told that you need a least common denominator, but that is not necessarily true. As long as you have a common denominator, you are able to add the fractions just fine. In this case, the least common denominator is a little bit more obvious. It would be 4. So I want to make sure both of my fractions are in terms of fourths. To do that, I would need to multiply the denominator of 1/2 by 2. But I can't just multiply the denominator, otherwise that changes the value of the number. So I'm going to multiply by 1, which won't affect the value of the number. That will leave me with negative 3/4 plus 2 over 4. Now that my denominators match, I can add their numerators together. And negative 3 plus 2 would be negative 1 over 4. Let's move on to multiplication and division, and evaluate each of the following here. Remember, when multiplying and dividing real numbers, if the signs match, the result is positive. If the signs are opposite, the result is negative. Then we multiply or divide normally. Like in part A. Here I have opposite signs, so I know the answer is going to be negative. And then I multiply the numbers normally. 5 times 4 is 20. Same rule goes for for letter B. I have the same signs, negative 6 and negative 3, so I know my result is going to be positive. Now I just multiply the numbers normally. Positive 18. Last problem here. Why don't you see if you can pause the video and do part C on your own? Hopefully we were able to get negative 5. Notice I have opposite signs, so I know my answer is going to be negative, and then I do the division normally. 15 divided by 3 is negative 5. Next, let's review exponents. Remember that exponents are just repeated multiplication. So when I see 5 to the third power, that denotes 5 times 5 times 5. Or 5 multiplied by itself 3 times. The way I think about it in my head is as 3 copies of 5. And I know 5 times 5 is 25. And then 5 times 25, maybe we don't know this one off the top of our head, but it's not too tough to check, is 125. Now, things get tricky when you start throwing negative numbers into the mix, because this idea of repeated multiplication still stands. Let's take a look at part B. In part B, we have negative 6 squared. Because the negative sign is included in those parentheses, this means negative 6 is the thing being multiplied by itself. Two negatives, we just learned, make positive. So my answer should be positive 36. This is not to be confused with negative 6 squared. If I had negative 6 squared, notice negative 6 isn't the number being squared. 6 is the number being squared. And I get negative 6 times 6, or negative 36. This is a note to be extra careful when dealing with parentheses. That said, why don't you see if you can try part C, which involves the same kind of trick, on your own? Go ahead and pause the video here and press play when you're ready. The answer to this problem is positive 16 over 81. Notice when I multiply those negative 2/3 by themselves 4 times, I have a negative and a negative, which makes positive, times a negative makes it negative, times a negative makes it positive again. And then, of course, when we multiply fractions, we multiply our numerators together and multiply our denominators together separately. So that leaves us with 16 over 81. Last but not least, I would like to remind you all of how to divide fractions, or taking division as a special case here, because sometimes it can get complicated. Like in part A, I've got negative 1/2 divided by negative 7/9. Remember, to divide by a fraction, we multiply by its reciprocal. That is, we write negative 1/2, we change our division to multiplication, and we flip the right-hand side over. I'm going to remind you of this fact a lot over the next few videos, but this is a very common mistake that I see as well when dealing with fractions. So remember, now I can multiply them normally. Remember, I have a negative and a negative, that gets me a positive final answer, and then I multiply my numerators and denominators together. 9 times 1 is 9, over 2 times 7, which is 14. So 9 over 14 would be the correct answer here. Part B is to remind you of a very nice case involving 0. In the same sense that multiplying anything by 0 gets you 0, 0 divided by anything is just 0. So even if I have 0 over some weird number like 4.6, I still get 0 as the final answer. Part C is a little bit of a trick question, but I want you to pause here and see if you can figure it out on your own anyway. The correct answer to this problem is negative 1 over 36. But let's see how I got that. First and foremost, I've got a negative and a positive being divided, so I know my answer is going to be negative. Now, this example serves as a reminder that all of our integers can be written as fractions or rational numbers with a 1 in the denominator. So when I see negative 2 over 9 divided by 8, I can think of that as the equivalent problem, negative 2/9 divided by 8 over 1. And now I can treat this just like I would part A, where to divide by a fraction, I multiply by its reciprocal. So I rewrite this problem as negative 2/9 times 1/8. Now I multiply my numerators and denominators together separately, and that leaves me with negative 2 over 72. Something I would like you to get in the habit of in this class is to fully simplify your answers. And we'll get a little bit more into detail about how simple is simple when it becomes more appropriate. But for now, I noticed that there was a factor of 2 in both the numerator and denominator that I was able to cancel, leaving me with negative 1 over 36. Last but not least, part D asks, what is 12.7 divided by 0? The answer is nothing. This number doesn't make any sense. It is undefined. Dividing by 0 is kind of a nonsensical thing to do. And let me explain it to you this way. If you had $12.70 to split up evenly amongst no one, how much would everybody get? Well, it doesn't really make sense because there's no one to pass the money out to. Remember, you cannot divide by 0. This is going to be a recurring point of contention that's going to come up throughout the rest of our class. From this video, you should be taking away how to add, subtract, multiply, and divide real numbers. In the next video, we're going to take a look at what order these operations should be done in when multiple of them appear in the same expression. I'll catch y'all in the next one.